So the learning target this unit was working with different number systems and also different bases of number systems. Number 9, that we struggled on a little bit. 13% of us got correct. Ask you to use the table powers of 16 to convert 2AD hexadecimal or base 16 to our common base 10, aka decimal. So what we've got 2 in the 256 spot, we got A in the 16 spot, and D in the 1 spot. Oh, that's really simple. The first part, 256, is happening 2 times. So we got to do 256 times 2. 6 times 2 is 12. Regroup the 10s or carry the 1. 5 times 2 is 10 plus the 1, 11. 2 times 2 is 4 plus the 1. We've got 512 from 2 256s. So now the A, and on the test, you were reminded, that means we have 16 happening 10 times. 16 times 10 is real simple. It's 160. So we'd have to add that on to 512. And then D is worth 13. So we have 1 happening 13 times. So altogether, we've got 512 plus 160 plus 13. If you need to stack it up, do it real quick. I really don't think you have to, but we got a 2. 6 plus 1, 7. 5 plus 1, 672 plus 13 more. My mental math, 672 plus 10 is 682 plus 3 more, 685. So come up with a new hexadecimal. I'm expecting to have at least 1 letter. It should be at least 3 hexadecimal places long. So you should have to have something in the 256 column, something in the 16 column, something in the 1 column. Guess you could throw 0 in some of them, but the 256 better happen. Okay. And I'm expecting at least 1 number in each spot. Not no digits of 0. Because otherwise you just go, oh, I got a 256, 0, 0, so I got 256. No, I'm not taking it. Okay, number 10. You were asked to convert hexadecimal, which is base 16, to binary, which is base 2. I remind you right there. Binary to decimal, which is our common base 10. We don't normally show a little 10 by it, so that's why it's not shown. And then finally decimal into quinary, which is base 5. We've said the simple way that Mr. Khan showed us that I reviewed extensively over and over and over again. Turn C. C is, again, 12. Turn 12 into binary, just the 12. So we're only working with the C right now. Well, 12 in binary, we've got 8, 4, 2, 1. We've got 1, 8 and 1, 4, and 8 plus 4 is 12. I don't need any 2s or 1s. And then turn the other place value, the 7, into binary. Well, 8's not going to be used to count to 7. So that's a 0. But a 4, 2, and a 1, 4 plus 2 is 6 plus 1, 7. So in binary, our answer that we could list either here, like what we should have typed into the computer, or we could list here, which I think is really helpful for the next part. We've got 1, 1, 0, 0, 0, 1, 1. And now what we need to realize, that C is actually worth 16. We had 16 12s happening there. Well, 12 16 times, 12 16 times would be 128 plus 64. So when we go from binary to decimal now, we said, hey, that's actually a 16, so put a 16 there. That's actually a 32. That's actually a 64. That's actually a 128. Why? Because that C is in the 16 place values. So we have 12 16s. We have ultimately 128 plus 64. So these two. The math there, 8 plus 4 is 2. Regroup the 10s, carry the 1, whatever you want to call it. 6 plus 2 plus 1 is 9. Bring the 1 down, 192. And now 4, 2, 1. That's really easy. Add on 7. We have 199 in decimal. Last part, quinary. Quinary is base 5. So I think you got a chart that looked like this. We need 125s and 25s and 5s and 1s. They're all powers of 5. Oh, we got 125 in 199. Our remainder, whether we write this out or we do this in our head. 9 minus 5 is 4. 9 minus 2 is 70. How many 25s go into 74? 2 whole ones. 2 times 25 is 50. That leaves 24 left over. How many 5s go into 24? 4. 4 times 5 is 20. 24 minus 20 in my head is a remainder of 4. So in quinary, our number is 1244. Please use this to recreate a problem. Again, hexadecimal should have 2 place values, 2 digits. They can't both be 0, and then you're turning it into binary, decimal, quinary. You do all that, maybe your test grade goes up by as much as 25%, depending on how well or how poorly you scored.